Welcome again to the continuation of the topic matrices. We want to look into types of matrices. Types of matrices. Types of matrix. Okay, we have 10 types of matrix. One is row matrix. What is row matrix? Row matrix is a matrix with only one row. It's written this way. Remember that the elements or entries of a matrix is written or packaged inside a bracket. So it's written this way: 2, 3, 1. How many rows? One row. The order or arrangement of the matrix of row matrix is 1 by 3. That is 1 row by 3 columns. I repeat, row matrix means matrix with only 1 row. Then the order or dimension of a row matrix starts with 1. So this one is 1 by 3 because the column will be what? 3, but the row will be 1. If you have it this way, 2 and 3, this will be 1 by 2. That is 1 row against 2 columns. So either you write it as 1 by 2 or 1 times 2, or you write it as 1 by 2. This is 1 by 3. Okay, so the next one is column matrix. Column matrix. Column matrix is a matrix with only 1 column. It is written this way. Given matrix A equals to 2, 3, 1. You say that the order of this matrix is, the column will be 1. How many rows? 1, 2, 3. 3 by 1. If it is like this, 2 and 3, the number of rows will be 1, 2. 2, and number of columns will be 1, 2 by 1. So you see that in row matrix, is the order of it starts with 1 and ends with any number. While in column matrix, the order of it ends with 1 and starts with any number. So take note of it. We go to the next types. We have what we call square matrix. Square matrix is a matrix that have equal number of rows and columns. I repeat, square matrix is a matrix with equal number of rows and columns. We've been able to know what is row and column. Now, 2, 3, 4, 1. This is an example of square matrix. Why? Because the number of rows is 1, 2. 1, 2. So 2. The number of columns is 1, 2. 2. So they have equal number of rows and columns. We go to the next one, rectangular matrix. Rectangular matrix is a matrix that have unequal number of rows and columns. It's a matrix that have unequal number of rows and columns. Matrix A equal to 2, 3, 1, 2, 4, 1. How many rows does this have? 1, 1, 2. How many columns? 1, 2, 3. 2 by 3. So they don't have equal number of rows and columns. The number of rows and number of columns varies. We go to the number 5th types, that is null matrix. A null matrix is a matrix that its elements are all 0. From the name null, all the elements in it must be 0. This is a 2 by 2 null matrix. This is 2 by 2 null matrix because the rows are 2 and the columns are 2. Then this is 3 by 3 null matrix. Why? Because number of rows are 3 and number of columns are also 3. So that is about null matrix. Number 6 is diagonal matrix. Diagonal matrix is a matrix. Diagonal matrix is a matrix whose elements are all 0 except the diagonal elements. Diagonal matrix is a matrix whose elements are all 0 except the diagonal elements. This is a typical example of diagonal matrix. Why? These elements are called the diagonal elements. So all the elements are zeros except the diagonal elements. That is why we call it diagonal matrix. Okay? Then we go to the next type of matrix, which is unit matrix. Unit matrix is a matrix whose elements are all 0 except unit matrix. This is a matrix whose diagonal elements are 1. So the elements are all 0 except the diagonal elements, which are 1. So the diagonal elements are equal when you talk about diagonal, when you talk about unit matrix. This unit matrix can be called identity matrix. So once you see it as unit matrix, know the example is this. This is a typical example of unit matrix, or you call it identity matrix. This unit or identity matrix has determinant of 1. They have determinant of 1. So the determinant of a unit or identity matrix is 1. This is called 3 by 3 units or identity matrix. Why this one is 2 by 2 units or identity matrix. This is 2 by 2 units or identity matrix. We go to the next type of matrix. And next type is called Scalar Matrix. Scalar Matrix. Scalar Matrix. A scalar matrix is a matrix whose diagonal elements are equal but not equal to 1. This is a matrix whose determinants are equal but not equal to 1. Take an example. This is an example of scalar matrix. 3 by 3 scalar matrix. By 2 scalar. So the diagonal elements are equal but not equal to 1. The diagonal elements are equal but not equal. Once the diagonal elements are equal, you know it is unit. But once the diagonal elements are equal to 1, you know it is unit. But once the diagonal elements are not equal to 1, you know it is the scalar matrix. So we go to the next type of matrix called singular matrix. As I said, there are 10 types of matrix. This is scalar. Then 9 singular matrix. A singular matrix is a matrix which determinants are equal to 0. Singular matrix. This is a matrix where determinant is equal to 0. This is an example of singular matrix. We'll see go into determinants of matrix in full detail. But it said it is a matrix whose determinants are equal to 0. How do we get determinants in a nutshell? It simply means these elements are called diagonal elements. Diagonal elements. Why these elements are called off diagonal element. So when we talk about singular matrix, we say the determinant must be equal to 0. Determinant simply means the difference between the product of diagonal elements and off diagonal elements. I repeat, determinant of 2 by 2 singular matrix. Determinant of 2 by 2 matrix simply means, because this is 2 by 2, determinant of 2 by 2 matrix simply means is the difference between the product of the diagonal elements and off diagonal elements. So this is diagonal element. 2 times 3, 6. You put minus. 6 times 1, 6. 6 minus 6, 0. So this is a typical example of singular matrix because the diagonal because the determinant is equal to 0. But if the determinant is not equal to 0, you call it non-singular matrix. Non-singular matrix is a matrix which determinant is not equal to 0. This is a typical example of 2 by 2 non-singular matrix. Why? Because the determinant of it will not give us 0. What is the determinant? Multiply the diagonal element. 2 times 1, 2. Minus, multiply the off diagonal elements. 3 times 4, 12. That will be giving you minus 10. So minus 10 is not equal to 0. So you say it is non-singular matrix. Mind you, before you write determinant, you must put this symbol. This means you are looking for determinant of that matrix. So determinant will be equal to minus 10, not 0. Why the determinant of this one? Determinant of A will be giving us 0. So when the determinant of a matrix is 0, you say it is singular matrix. But when it is not equal to 0, you say it is non-singular matrix. Keep in touch with our video because we'll see more on this matrix. We have to learn how to get equal matrix and a lot of things on it. Keep in touch with the video. Don't forget to subscribe to our YouTube channel, like our video, and keep in touch with us. See you next time.